Okay, we're in section 1.6, which is graphical transformations. We're going to look at how we change graphs by shifting them left and right and up and down and reflecting them and all sorts of different type of graphical changes. First, before we start any of our notes, I do want to make a quick change on here. I want to change this to say across the y-axis and then on the other side to be across the x-axis. That will group our information according to their basic change, which is horizontal versus vertical. Okay. So along the left side here, we have horizontal translations. Reflection across the y-axis. So if I think about changing across the y-axis is vertical, that's a horizontal change. And then horizontal stretches and shrinks. These all are grouped together. Anything that happens horizontally, sideways, those are x values that move us across, move us right and move us left. Everything here in this column is going to be affected by changes to the x. Okay, all of this whole column. Vertical transformations, if I translate, means move up and down. Reflecting across the x-axis is a vertical change. And then vertical stretches and shrinks. If I take things and stretch it and shrink it vertically, it's all about the y value. So here we're going to have changes. Remember, the y value is the whole function. So to the function. And we're changing to the whole f of x. Okay, having that basic knowledge is going to make all these changes much easier to understand and put together. Okay, let's start with thinking about simple translation. A translation just means I take the graph and I shift it up or left or right or whichever direction it might be, but I don't change the shape of it, I just move it. Okay? The way we can generalize to say if we want to move the graph left and right, I want to change my x. So in with the x here, I'm going to put, say, a plus c. Okay, if I take my function and everywhere I see an x, I add some constant value to it, it will take the graph and move it. Now remember, anything with the x is opposite of what you'd expect. So an adding of c moves it left c units. And then if I have a subtraction of c, that's going to move the graph right c units. Sorry, that actually looks like one word. Shift that up a little bit. Okay. Vertically, if I want to change the graph and move it up and down, then I'm taking the whole function as it is and simply adding some value to it. If I add c, this is a direct translation. It actually moves me up c units. And if I subtract c, it moves me down c units. So that's our changes when we're moving directly up, directly down, left and right. No change in the shape of the graph. Okay, we have other translations, and some of those are simply reflections. So I'm going to reflect the graph across the y-axis. Okay, y-axis, remember that's your vertical axis. So if I want to reflect a graph across the y-axis, it ends up being a horizontal change. And to do that, again, everything horizontal applies to the x. We take the opposite of every x. So wherever there's an x, we put in a negative x. This gives me my horizontal reflection. Okay, similarly, for a reflection across the x-axis is horizontal. That means I'm moving up and down as I'm reflecting across that axis. So it's applied to the y values or the whole function's value. This time, instead of taking the opposite of x, we actually take the opposite of the whole function. That gives us our vertical reflection. So we have moved the graph left and right by adding to the x, up and down by adding to the whole function, reflecting across the y-axis by taking the opposite of x, reflecting across the x-axis by taking the opposite of the whole function. And then we need to now, these are what we call rigid transformations. Let's actually identify that these are rigid. They don't change the shape in any way. They just move it or reflect it. Now we're going to actually look at non-rigid transformations where I actually change the shape. I stretch it, I shrink it, I make it bigger or smaller. If I take a graph and I want to shrink it or stretch it horizontally, okay, maybe I have something like parabola that looks like this. If I stretch it horizontally, it gets much wider, okay, pulling it away from the axis. How that happens is again applied directly to the x if it's horizontal, and it's a matter of a division. Everywhere I see an x, I divide by c. And if I divide by c, and that c value is greater than 1, it stretches the graph. And remember, this is a horizontal change. If c is less than 1, it shrinks the graph horizontally. Okay, vertical, my guess is hopefully at this point you can make a little bit of a prediction here. If I'm wanting to stretch or shrink vertically, again, it's going to be a matter of working with the whole function since I'm vertical. This time, though, we do it as a multiplication. C times f of x. And if c is greater than 1, we stretch it vertically. And if c is less than 1, we shrink it vertically. Now all that's the information. Let's look at some sample problems. Let's start with example 1. Here we start with a graph of the absolute value of x. Hopefully you're picturing a V-shaped graph. And we want to know, how can this be transformed to the graph of the absolute value of x plus 4? Well, if I want to take this graph and I want to change it to this graph of this function, I need to take the original absolute value graph. Notice there's a plus 4 added to it. So if we look above, it's added to the whole absolute value, so it's added to the whole function. That is going to take my absolute value V-shaped graph, and I need to shift it up 4 units. Okay. As we continue on, we see other types of changes. So here now we're starting with a curve that's defined as y equals x squared plus 3. And we want to do some changes to it. It says find the equation for the following non-rigid transformations. So non-rigid means we're going to change the shape of this sum. The first one we're going to do is a vertical stretch. So C2, our new curve, is a vertical stretch of the old curve by a factor of 4. So vertical applied to the whole function. So my old graph, or my old function, is x cubed plus 3. I want to stretch it vertically, so I want to take that to find my new C2. I need to take the whole old function, which is y1, and multiply it by 4. So 4 times y1. And so I get that new curve, C2, as 4 times x cubed plus 3, which comes out to be 4x cubed plus 12. And now we want to look at, that's a vertical change, says multiply the whole function, the whole y, which is our whole function or x cubed plus 3. Now we want to look at a horizontal shrink by a factor of a third. So to find C3, curve 3, to work horizontally has the division. All the x values need to be divided by c, and c is 1/3. So I'm going to take x and I'm going to divide it by a third, just to see what's going to happen with this. All the x's, okay, not equals, let's put an arrow there. Because ultimately, it's, to find our third curve, we need to take all the x values and divide it by 1/3. Remember, division is multiplication by the reciprocal, so that's the same thing as 3x. So instead of changing all my x's and divide it by 3, I'm actually going to take them and divide by 1/3. I'm going to take them and multiply by 3. So what that new curve becomes, where there was an x, which x is cubed, so that where that x was, I'm going to replace it with 3x. And then cube it. And then I have the remainder of that, which is plus 3. And now simplifying that, I'm going to go ahead and cube this term and get 27x cubed plus 3. Okay. We have one last example here. And it's now going to be a matter of doing a bunch of translations to one function. We're going to start with a parent function, y equals x squared, our basic cubic or quadratic function. And we want to do these following translations, and we're going to do them in this order. So first I'm going to start with x squared, and I want to shift it horizontally 3 to the left. So to change it horizontally is an x value, so it's applied directly to the x. And so my function goes to, we're going to write small because we're going to fit in 3 lines here. Y equals x minus, we want to go left, sorry, so we want to go plus. Remember, that's in the opposite direction. X plus 3 squared. Okay, that takes my graph and shifts it left 3. Now I want to, so that's done. Okay. After that, I want to do a vertical stretch by a factor of 2. Vertical stretch, vertical is applied to the whole function because it's applied to the y values. So I want to take the whole thing and multiply by 2. So 2 times the x plus 3 squared. Okay, so we got that taken care of. And then I want to do a vertical translation down 4. So I want to take, again, down applies to the whole value of the function. Down 4 means I'm going to subtract 4 from it. So finally I get to y equals 2 times x plus 3 squared minus 4. That is my new function that started as x squared and had these 3 translations performed on it. Okay, now look at, we're going to try the same thing, but we're going to go in the opposite order. We're going to start with a vertical translation of down 4. So we start with x squared and move it down 4. It's applied to the whole function because it's vertical. Now I'm going to vertically stretch by 2, so I'm going to apply that to the whole function. I'm going to multiply the whole thing by 2. Okay, I'm going to take a moment and go ahead and simplify that to make that 2x squared minus 8. Okay, so I multiplied the whole function by 2. And now I want a horizontal shift left 3 units. So now I've got to take that and apply it to the x. And I'm going to apply it in here, so I get y equals 2 times x minus, or x plus because it's going left, 3 squared minus 8. Okay, notice that's different than before. One thing to take note of is that order matters with our translations. Okay, I want you to take a moment, hit pause right now, and try and fill in the blanks that are below. Decide what translations happened from the basic parent function, so we don't know what it is, it just tells us f of, so it's some function, and we want to figure out what happened. So you fill in those blanks, so pause now. Okay, hopefully you have it already filled in. Let's double check it. So because of the plus 3, we're going to shift left 3 units. Okay, and that gives us the f of x plus 3 part. Then we have a reflection across the negative is applied to the whole f of x. So that's across the x-axis. Remember, x-axis is the vertical change. Okay, to obtain negative f of x plus 3. And then last, we have a vertical, multiplying that 2 is applied to the whole function. So vertical multiplying by 2 is a stretch by a factor of 2 to obtain our negative 2 times the f of x plus 3. Okay, we will be doing a lot of practice of this when you come to class, so hopefully you have this ready to go. Thank you.